Good morning, everyone. Welcome back to Biological Imaging. I'm Joe DeGeorgis. This morning we're going to do a plankton tow out here in Great Harbor in Woods Hole. And we have a very fine plankton net that has a fine mesh of 25 nanometers. That's the whole size of the mesh. So it's collecting very, very small organisms. And the plankton net itself is shaped like an ice cream cone. And at the bottom, it has a plastic container which catches the plankton. So I'm going to start up the engine and we're going to let this net out behind the boat and we'll tow it for about 5 minutes and then bring it back in. Here we go. All right, the net's out. Get our engine started again. Okay, now we're just going to pull our net back in. So I can see that I have some plankton in here. And I'm going to open up this plastic container or take it off. And the plankton will fall free into the bucket. So you can see it looks dirty, but that's not dirt, it's marine life. That's the plankton. So I'm going to pour the plankton in here. And I'm going to rinse the net off a little bit to get any other plankton that might be on the net. See, it looks dirty, but I assure you, that's marine life in the North Atlantic. So we'll bring it to shore and we'll take a look at it under the light microscope. Hi everyone, welcome back to Biological Imaging. So I came into the classroom and of course put on a pair of gloves, and I already cleaned off the eyepieces with the Windex and paper towels. I booted the computer and I logged in using bioimaging. I put the SD card into the camera. I turned the camera on. I loaded the EOS utility and I futzed around with that a little bit, turning the camera on and off and reloading EOS utility until I could get the computer and the camera to communicate with one another. And now I have the control panel up, and I'm going to just show you a couple of things with the control panel, because I wasn't able to record the cursor in some of our previous tutorials. So I want to go through that one more time, and then I'll leave that set up to you guys. So once we have the control panel up, this is the shutter button, as we've talked about many times. I want to create a new folder by clicking on this folder icon, going to Browse, selecting Desktop so that my file folder will end up on the desktop. Go to New Folder, let's call Joe's Plankton Images. Okay, and then Create, Open, hit OK, and now you can see that we're saving the images to Joe's Plankton Images, and of course here's our folder. Once again, I'm checking to make sure that the camera is set at aperture priority, which is capital A, small v, so that's correct. Our ISO is set at 100, so if I double click on the ISO I can change it, but we want it to be at 100 right now, so that's fine. We're once again shooting a RAW file plus a large JPEG file, and we're saving them to the computer, to our folder on the desktop called Joe's Plankton Images, and of course we're also saving those images to the SD card. This is exposure compensation, and I want that to be set at 0, which it is, at least to start. And so now we're ready to open up the live view window. And here we go. Now I wanted to go over curler illumination once again. Here again you can see that there's light coming from the condenser lens and making it into the objective and then eventually to the camera sensor. But this is not centered. What we're trying to do is align the condenser lens with the objective and then focus the light coming from the condenser lens onto the sample and then focus the objective onto the sample so that the image is sharp and captured by the camera on the camera sensor. So the easiest thing to do is to start with a slightly higher magnification than the 5x. I like to start with the 10x. And I'm going to pick a slide from the slide box. And the slide that I have, the sample that I have is an earthworm cross section. So I'm going to place this on the microscope stage and place it in the microscope holder and hold it in place with the spring action arm. Then I'm going to move the sample over and find the sample by using the eyepieces until I can see the sample, and then I'm going to use the focus knob to focus on the section. Okay, now the sample is relatively focused, and I'm going to try to center the condenser lens or align the condenser lens with the objective by rotating these two manipulators. So I'm going to turn the right one first, and it's starting to move the light towards the center and then the left one. And now I'm going to decrease the field diaphragm, which is an aperture down here. I'm going to turn it counterclockwise, and that makes the light source smaller. And now I'm going to use the condenser lens focusing knob, which is this knob here, which is in front of the objective focusing knob and slightly above it. And I'm going to turn that focusing knob until I can see the edges of the field diaphragm, like that. I'm going to turn the light down a little bit because it's a little bit bright, using the knob on the right-hand side in the back, which lowers the voltage and the amount of light that we're just turning down the light source. Okay, so now we can try to refocus our sample a little bit, although that still looks fairly well in focus. And now I'm going to again try to recenter the condenser lens and then focus it again until the edges are sharp. Okay, now I'm going to open the field diaphragm a little bit, and that looks pretty good. I mean, we're a little off to the right, so I'll just try to do a better job on that. And then once again, I can refocus the objective, that is, focus the sample. Then I can refocus the condenser lens, and the light source looks centered, or the condenser lens looks centered. And now I'm going to reopen the field diaphragm just enough so that it fills the entire live view window. Now we're set. The problem is, as you can see, the white balance is once again off, and so I'm going to open the window of white balance right here, these three little lines. I'm going to click on that, double click on it, I guess. I'm going to make sure that this box is checked that says apply to all shots, because once we set the white balance, we want that to apply to our images. And to correct the white balance issue, I'm going to select the eyedropper. It reads custom. I'm going to select OK. So I could use the eyedropper on an area within the piece of tissue that doesn't have any tissue on it, that is a blank part. But I'm going to move off the piece of tissue to the edge of the slide and use that area as my reference point for the white balance. Now I want to unclick the eyedropper, and I like to close the window. And now we can move our sample back in place. Okay. Now we can take a photograph by mousing over the shutter. Now we can see, again, here's our shutter speed. So when we mouse over the shutter, this box opens up and we can see that we have a very, very slow shutter. So now I want to increase the light. This shutter speed's too slow. So I'm going to increase the voltage to the light bulb, again with the knob on the right-hand side of the microscope in the back. And I'm going to mouse over the shutter, and I can see that the shutter is getting faster, 1/30 of a second, 1/30, I'm sorry. And then I'm going to keep increasing the light until we get up to about 1/125, right there. Now we can see that by changing the voltage on the light bulb, we have this blue cast to it, so we need to adjust the white balance again. Every time we change the intensity of the light, we need to check the white balance, because changing the voltage on the bulb changes the color temperature of the light that's being emitted from the bulb. So I'm just going to go to this spot here and click, and now that achieves proper white balance again. I'm going to close this and then close the window. So we're all set now. We can take a photograph by coming over to the shutter and pressing the shutter. My shutter speed is 1/125. Here's my final image. It's MG_9964. This is the camera raw file, so CR2 is the designation. And of course, if we go to our folder, Joe's Plankton images, we see that there were really two shots taken. One is a camera raw file and one is a JPEG file. Of course, those two images are also being saved on the SD card in the camera. Now this image here looks a little bit too dark, so I'm going to increase the exposure, and to increase the exposure in an automatic setting like aperture priority, the only way that you can increase or decrease the exposure is by using exposure compensation. So I'm going to double click on exposure compensation, and I want it to be brighter, so I'm going to move these white lines towards the positive side by clicking this little arrow, and that's 1/3 of a stop, and that's 2/3 of a stop. And I'm going to try a photograph at that image. Okay, so it's brighter. Maybe this one's too bright, so I'm going to come down here and go to just 1/3 of a stop. Okay, I like that image. Now if we wanted to make a scale bar, we could compare this image to the image that we took of the micrometer using the 10x objective. We have to use two images that were taken with the same microscope objective, one being the micrometer and one being the tissue or your sample, and we could draw in that scale bar. But now I want to go to our sample that we collected this morning, the plankton toe, up in Woods Hole, and now we're back in the classroom. Of course, I brought that sample with us, and I'm going to show you how to prepare a slide, and then ultimately we're going to photograph some of the samples using all of the different microscope objectives, including the 100x, which requires oil. So I'm going to show you how to do that. Okay, so here's the bucket that we had this morning on the boat, and I'm going to show you what it looks like inside. And it looks just like dirty water with some stuff on the bottom. But it's not dirty water. Very little of this is dirt. Most of it's marine life. They're planktonic organisms, very small critters. Some of them are unicellular. And most of this material is alive. Okay, now we're going to make a slide of the plankton. I'm just going to open the box up and pull one slide out, if I can. So one glass slide. These are the cover slips. And I have a transfer pipette, and I'm going to reach down into the bucket, and I'm going to take up some of the stuff that looks like dirt and place it on the slide. So I don't want to take the water off of the surface because most of the marine life has settled to the bottom of the bucket. So I'm going down to the very bottom with my pipette and sucking up a little of this sample. And now I only need one drop, no more. It's fine, you're not going to hurt anything by having more than one drop, but the cover slip starts to float around and it makes your life a little bit more difficult. The glass cover slips are extremely small, extremely thin rather, and I kind of lay one edge along the microscope slide and then let the cover slip drop onto the surface of the sample, and now we've made our slide. Now I'm going to put this in the light microscope. Okay, so I'm going to remove the existing slide of the earthworm, and I'm going to replace that slide with the plankton slide. So right away we can see that there's a lot of living cells in this sample. Some are just skeletons, the remains, like this down here. but others are perfectly alive, like these samples. They look quite nice. So I'm going to try to compose this a little bit. Then we can try to focus in on this. We're still at the 10x objective, but now we can try to see if we can get this a little bit sharper before we take the photograph. Something like that. Then I'm going to close the zoom view window and I'm going to take my photograph. I'm going to check my shutter speed, still 1/25. That looks great. I'm going to take a photograph here. And here's my final photograph. It looks like it might be a little dark again, so I'm going to try to reshoot it by changing exposure compensation to plus 2/3 of a stop and take the photograph. It looks a little better. And now I'm going to move to a different area, see what else we can see in the sample. There's an air bubble. Whoa. Well, this is some sort of critter. I don't know what it is. But you can see some sort of eye here. So I'm going to focus on the eye, double click, and then blow up the eye. And then try to focus on that a little bit. Looks like a rabbit in that shot. And then I'm going to close this window and take my photograph. Okay, now let's find something a little smaller and we'll try to go up in magnification. Maybe this guy here. Let's see what we can do with him. Put him in the center. And then I'm going to double click. And there he is. And I'll take a photograph at the 10x objective. And now I'm going to go up to 20x. So I'm going to swing the 20x objective in place, which of course has the green color code, and refocus the sample. Because the sample is so three-dimensional, depth of field becomes an issue, and I'm going to talk about this a little bit more later, but as the magnification goes up, the depth of field goes down. So you have to pick what part of the specimen you want to have in focus. And I'll take my photograph up. See, if I mouse over the shutter, I can see that my shutter speed is 1/40. So that's too slow. I'm going to set this back at 0 for now, and I'm going to increase the power of the bulb and mouse over the shutter so that I can see my shutter speed changing. I'm going to go up a little higher this time. Well, I maxed out. I'm totally at the top of the power button, and it's at 1/60th of a second, which is certainly acceptable. But of course, when we change the voltage or the intensity of the light bulb, it changed the color to a more bluish tint. So I have to check my white balance again by clicking on the window, by selecting the eyedropper, and then picking a part of the sample where there's just glass and click on that. That gives me the correct white balance again, and then I can close and turn off the eyedrop tool and then shut the window, and now I can take my photograph. And if I want it to be a little bit lighter, then I can increase the exposure using exposure compensation and take the photograph again. Okay, now let's go to 40x. Here's 40, which has the color code blue, and try to focus my sample again. And once again, now my shutter speed is low. It's only 1/25. So I can't increase the power of the light anymore because it's maxed out. So the only way I can get a faster shutter speed is to increase my ISO setting. So if I go from 100 to 200, that's making the sensor twice as sensitive, but the camera is going to try to keep the exposure the same. So it's going to increase my shutter to twice the speed of 1/25, which is 1/50. So if I mouse over this, see, you get 1/50. And if I increase this now to 400, which is twice as sensitive as ISO 200 or 4 times as sensitive as ISO 100, then once again it's going to increase my shutter speed from 1/50 to 1/100, twice as fast as 1/50. So I can refocus a little bit. And take my photograph. Now I'd like to try this with the 100x objective. And in order to use the 100x objective, you need to use a droplet of oil. It's specific oil designed for this purpose, and we have a jar of it in the lab. Okay, so I have some oil. This brand is by Zeiss, which is the same manufacturer as the microscope, and it's called 518N. They call it Immersoil. So all we need is one drop. So I've swung the 40x out of the way, and I'm going to place one drop of oil where the light is coming through the glass, and I'm going to swing the 100x microscope objective in place. So now the glass of the 100x eyepiece, the lens that is coated with oil, and the cover slip is coated with oil. So there's an oil barrier filling the space in between the microscope objective and the cover glass. And I can center, whoops, I'm going to go to the 5x because the 5x is very far away from the sample. I'm going to see if I can see my critter, which I can't. Okay, I lost that sample, so I'm going to try another one. I made a new slide, and I'm going to try to find something that we can look at. So to find a new sample, I'm going to go down to a lower magnification, down to the 10x objective, and I'm going to refocus because it's very hard to find something at 100x. So now we have our sample again here, and we'll take a look around, see if we can find anything cool. How about this guy? This thing is called a concentric diatom. And so we can go up to 20x. There's 20x. And then 40x. Ooh, there's another guy coming in. Cruising around, and I'll take a photograph. And there's our photo. And there he goes out of the image. So I'm going to center the diatom if I can here. And I'm going to double click on this just to look at the focus. And you can see it's hard to decide where focus exactly is. I mean, something like that maybe is close. I'm going to stop there. I can double check my white balance if I want to by going up to the stopper, closing that. And then once again I'm going to try to go up to 100. So I'm going to swing the 40x out of the way, and I'm going to put a drop of oil on the cover slip, just one drop. And then I'm going to swing the 100x objective into the oil. And I'm going to refocus this critter. And I'm going to try to center this. There's some other guy in there that's getting in the way here. Okay, it doesn't quite completely fit, but I'll stop there, and I'm going to focus. Yikes, someone is really trying to do us in. All right, I'm going to try something like that. But now, if we mouse over our shutter, we see that the shutter speed is 1/20. So now, once again, we have to go up in ISO because we're maxed out on the power. So I'm going to try 1600. That's still 1/80. That's a little slow. I think I'm going to try it there because this critter's not moving, and so we should still get a shot. Well, it's moving a little bit. Let me check the focus. What's happening is that when I try to focus, we're pushing on the cover slip, and pushing on the cover slip is causing the critter to move around a little bit. All right, so I'm going to stop there and call it good. Let me just let it come to a stop and then take my photograph. So the depth of field is so shallow at 100x that we need to look at very thin organisms, things that aren't very three-dimensional. But here we are, there's our photograph. Now, if I want to try and make a scale bar, then I have to pick up our micrometer slide, and I have to replace our sample with our micrometer slide, and I'm going to start at a lower magnification so I can find the scale bar. Find the micrometer, rather. It's a little hard to find it at 100x. There we go. So there's our micrometer bar, and again, I'm going to try to slide this over to one edge, like this. I'm going to focus it a little bit, something like that, and I'm going to straighten it out by turning the camera a little bit, like so. And then I want to be able to see the numbers. Whoops, that's the wrong way. Here are the numbers, and slide this edge over again a little bit, something like that. And once again, we said that this is 1.0 millimeters. And now we're going to go up in magnification, and these lines here are separated by 0.1 millimeter. So now if we go up to the 20x objective and refocus, and then try to set the edge of the micrometer on the right-hand side of the live view image, you can see that the width of the live view image is 0.5, 0.6, about 0.65 millimeters, which makes sense because we said that with the 10x objective it was about 1.3 millimeters. So half of 1.3 is 0.65. Now we need to swing in the 40x objective. And then line up our edges like so, and refocus. And now I'm going to move the lines more towards the center of the microscope, because once we get to 100, these finer gradations are going to be important. So there we go. So this is 0.1, 0.2, 0.325 millimeters, which makes sense, or 350 microns or micrometers. Now we're going to swing the 100x objective in place, and so once again, after I swing the blue 40x objective out, I'm going to place a drop on the micrometer, and then I'm going to try to swing the 100x objective in place, like so. I'm going to focus, and then I'm going to move this over a little bit, and we can now see the finer. It's a little tough to get this right at the edge. All right, something like that. And you can see that it's about that this is 0.1 millimeter from this line to this line, and then maybe another, so this is 0.1, this might be a half or a third or something like, let's see, 1, 2, 3, it looks like about a third. So it's about 0.13 millimeters, which makes sense. If the 10x objective has a width on the live view of 1.3 millimeters, then at 100x it should be 0.13 millimeters. So that works out. Now we can take our photograph. There we go. And we have a photograph of our micrometer at the 100x objective, and we have a picture of our concentric diatom at that magnification with that objective, the 5x objective. So now I'm going to close out our EOS utility, And I'm going to open this up again, and let's see if we can figure out, this is our micrometer bar, 9976, but let's use the raw file 9976. So this is our micrometer bar. So I'm going to drag that to Photoshop. And, whoops, okay. All right, let's open this image. And then I'll pull Photoshop down. 9976 was our micrometer bar. That means 9975 must have been our concentric diatom at 100x. So now we have our concentric diatom. And we can open up this file, and we have both of these images. So this is our concentric diatom, and this is our micrometer bar. And we said before that if you now go up to Window and then select Arrange, and then go to 2-up vertical, then you can see the images side by side. And then you have to left click on the image and then hit Command and the minus key, which is the key next to the 0, just to the right of the 0. And I'm going to hit that twice, and then I'm going to left click on this image and hit that twice. And now we have these two images, both taken with the 100x objective and then at the same size as one another. Now, to draw the scale bar, we have to go to the line tool, which is often usually the default is the rectangle tool, but here is the line tool. We selected that last time. 50 pixels looked okay. Let's make one at 40 just to be a little different. So we have to select the, oh, I'm sorry. That's not the right spot. We can set that at 0 again. We need to change the weight here, 50 to 40. And then now if we left click on our micrometer bar, and we can go from the middle of one of these and make it 1, 2, let's make it 3. This is 3/10 of a micron. To make it perfectly straight, you select Shift, and that makes it perfectly horizontal. And then you release your mouse, you release the Shift key, and now we have this line that's 1, 2, 3 bars wide. Now we go to Layers, and the shape of that is now in this layer called Shape 1. And all we do is click on it with the left mouse, hold the left mouse, and drag it over to our diatom. Then we can select this tool that moves the scale bar. And then we have to type in our distance. This is 10. This from here to here is 10 micrometers, 20 micrometers, 30 micrometers. So we have to select this image and the text. What's going on? And type in 30 micrometers. And then I'm going to select this Move tool, and I'm going to center this a little bit, and then I'm going to use the up arrow to move it a little closer to the line. And there we go. There's our scale bar. Now I'm going to save this as a different image. So I go up to File, I go to Save As, and I'm going to call this C-O-N, diatom with, with scale bar. And it's going to be saved to Joe's Plankton images. I'm going to say save. I'm going to say OK. Include layers, sure. Okay, so I'll save this file too as micrometer 100x objective. And now I can close out of Photoshop. I am going to turn the camera off. I'm going to take out the microscope slide and I'm going to wipe off the oil with a Kim wipe or a paper towel. And I'm going to turn off the microscope itself. And eventually I'll turn off the computer. I'll throw the garbage away, throw my gloves away, wash my hands, and I'll throw the glass slides, the ones that are disposable, the ones that we made of the plankton toe, into the glass disposal container. All right, you guys, that's it for today. Have a good weekend.